Hi everyone. So far we have covered a few basics of IP addressing, which is dotted decimal notations and few other things. And then we have seen what is classful addressing also, right? Now we have seen that what are the problems with the classful addressing. So we will be going with some other type of addressing, which is called classless addressing. So now we will see something called as classless addressing, and then few other topics like small topics are there. So don't worry about too much of number of topics that I've listed. Okay, most of the topics are very small topics. Then we will see what is network mask, subnetting, forwarding table of a router, longest prefix match, and then we will see determination, how to determine number of subnets. Then we will see the network boundaries. Then we will see the supernetting. Okay, so these are the few topics that we are going to see. So let's just start with the classless addressing. So what is classless addressing? See, here there is no class. I mean, there is no, since there is no class, then that's why there is no prefix, which is very implicit. So that's why we have to tell the prefix or the network ID explicitly. For example, we need to specify the network ID or the prefix with slash notation. So I will tell you what does this mean. For example, when I'm referring to some network here, so I will be referring that this is one network, this is another network, this is another network, like that, right? So these are the three different networks. What does this slash 8 means? It means that 8 is the network ID. Okay, so slash 8 means that first 8 bits are network ID. Okay, what does this slash 12 means? It means that first 12 bits are network ID. What does this slash 25 means? It also means that first 25 bits are network ID. So basically here if we want to tell about the network, then we have to tell the network ID explicitly, because there is no implicit. Okay, earlier this was a class A or something like this, but there is no class right now. Okay, so we can specify anything. Like earlier only the first 8 was the network ID, because for this kind of IP address, but now since it is classless, so we will specify, okay, first 12 bits are network ID, like that, right? So let's solve few questions, and then you will get to understand that what do I mean to say. Okay, so for example, this is classless, obviously. For example, if I'm saying slash 27, okay, this is representing one entire network. Okay, this is representing one network. Okay, this is representing one entire network. Now what does this slash 27 means? Okay, I mean, what does this whole IP address or whole range means? Let's just see. Okay, so since it is entire network, then what is the first address, what is the last address, and what are the number of addresses that are there in this, right? So what does this slash 27 means? It means that initial 27 bits are fixed. So this is 8 bits, then 16 bits, then 24 bits, and then 3 more bits from 82. Okay, so let me just represent this in binary. Okay, so I will represent this in binary, this whole IP address in binary, and then let me just fix 27 bits. So here these are the 24 bits and then 3 more bits, right? So these are the 27 bits, first 27 bits, right? So these are the 27 bits which are basically fixed. Now if first 27 bits are fixed, then which means these are the network ID. Okay, I mean, this is the network ID. Then what is the first address? First address means you can keep all of this as it is. Okay, so I'm writing in decimal, sometimes in decimal, sometimes in binary. I mean, depending on depending on the easiness of writing. Okay, so this is 199.170. Okay, then I'm writing the last part in binary. Okay, this is 010 is fixed. Actually, this is the network ID, and then these are the 5 bits which we can change, right? So the 5 bits here, for the first address, it will be all zeros, 5 zeros basically, 1 2 3. Okay, 4 5 5 zeros. This will be your first address. So this is the first address. I hope you understood. First address. I mean, this is not completely dotted decimal. You can convert this to decimal format, which is fine. This is 64, I think, right? So you can convert and you can write 64. So this is the first address, right? What is the last address in this particular network? What is the last address? So for the last address, you will keep the network ID as it is. Okay, this is the network ID. You will keep this as it is, and then you will say, let me put all the ones at the end. Okay, all the ones at the end. So these are the 5 ones. 5 ones means 32, 31, right? 1 2 3 4 5. So this is 31 plus 64. So whatever the number is, 64 plus 31, this is 595, right? So this is 95. Okay, this is 64. So basically this is the last address. Now last address will be 167.199.170.95. So this is the last address. Okay, so I hope you understood that what is classless. Extremely easy concept, just 5 minutes of concept. What is the classless? You specify with the slash notation, and to find out the first address, obviously you will keep initial 27 bits fixed, and then we'll change the remaining bit, and then we'll keep all the remaining bits 0, which is the first address. This is last address. Now since five bits are free, so number of addresses here are 2 power 5, right, which is 32. Total 32 addresses there, in which assignable addresses are basically 30. I mean, first address and last address you cannot assign to any host. So assignable addresses or the host addresses, if someone asks, then you can say 30, but number of IP addresses are 32 basically, right? Very easy. So you can see here, this is the first address, 64 is the first address, right, and 95 is the last address. Very easy, and that's how you can understand, and that's how you can solve this particular question. So the topic of classless addressing is actually over. I mean, this is just a 5-minute topic. Obviously, we will see with few more examples, and we will see in very good detail with gate PYQs, and everything will be there. But the crux is over basically. Like, there is no new concept that I can tell you now. Obviously, we will be having the practice, we will be having the gate PYQs, but in terms of the new concept, I don't think that I have anything to say now. Okay, so let's just see more. Okay, let's just see more. So what is the network address for this? Since it is /22, you will keep 16, and then this is 16 plus 6 more bits, right? So these are the 8 bits. So from here you will take 6 more bits. So you can represent this 12 in binary. 12 in binary means 8 plus 4. 8 means 1 followed by 3 zeros, and 8 plus 4 means basically 1100, right? This is 12, and then obviously these are the 4 zeros. So you can write 192.168.12.130. I mean, this is somewhere I'm writing binary, somewhere decimal, okay, depending on the need. So basically 22 means 8 16 and 6, which means you can just take 22, right? I mean, till this point everything is fixed. Okay, till this point everything is fixed. So you can say, if someone wants to ask the first address, then it is so this is basically 2 power 0, 2 power 1, 2 power 2, 2 power 3, right? So I think, yeah, this is 12 only. So so the first address will be 192.168.12.0, right? It will be 0. So what is the answer? B is the answer. Okay, I hope you understood. So that is easy question only, right? So what is the correct answer? The correct answer is C, right? Correct answer is C. Sorry, correct answer is B. Correct answer is B. Okay, that's very easy question. Now let's just move to the next question. So this question is saying, you're given an IP address. How many total IP addresses are there in this network? So they're just asking IP addresses. So 4 bits are free. So you can say 2 power 4, which means, let me go to the next page directly. 2 power 4 means 16. Okay, so you can say 2 power 4, which is 16. Okay, so the C is the correct answer. So here C is the correct answer. Understood? Great. Now let's just do this question. Yeah, this is little interesting question. Here in this question they are saying, which of the following networks are exactly same as this network? So basically here if you have noticed that we have been keep on saying that this slash notation represents the entire network, right? So if you write 152.3, let me just explain this question first, then you will get to understand that what does the slash notation clearly mean, right? .0.17 slash 17. Okay, so what does this mean? Maybe for the easy explanation, let me write 16 first, and then I will go to 17. I mean, 16 is basically easy to convert into binary decimal, because 16 means these two, octet, right? Okay, so what does this mean? It means that what is the network here? The network is basically these bits are fixed. So you can say it means this notation means, okay, this notation means that the first address is 152.3.0.0, and the last address is 152.3.12.0. 255.255, right? This is the first address in the here, this is the last address here. And the mask, or we also call it mask, I will come to that later. Yeah, but the notation is select 16, or the network ID is 16, right? Great. Now, just notice one thing here is that there are many addresses here. How many addresses? I think 2 power 16 addresses, right? 2 power 16 addresses in between. 2 power 16 addresses. Now, this is just one random address I have written. See, here, this is representing entire network. Then what is the significance of 128? The 128 does not have any significance, which means that you can take any address in this 2 power 16 addresses, which means as long as this is fixed, okay, this 16 bits are fixed, then you can write anything here, 3.5, okay, then select 16. So which means if you decode this address also, or if you decode this network also, then also you will be getting the same range, right? I mean, 16 bits are fixed, then or put all zeros and then put all ones, then you will be getting the same addresses. So basically as long as what I'm trying to say, this is 152.3, as long as if it is slash 16, as long as these two are fixed, then you put anything here, 3.5, which is same as, okay, which is same as 152.3 dot, you can put anything here, 1.0 slash 16, which is same as 152.3, because 16 bits should be same, and then you can write anything here, okay, .0.0 slash 16, which is same as, okay, 152.3.250.250, okay, slash 16, which is same as 152.3.255.255 slash 16, okay, like that. Understood? So what I'm trying to say, that once these 16 bits are fixed, then since it is select 16, okay, then it doesn't matter what you're writing afterwards. So basically all of these are representing the same network only. All of these are representing the same network only. Now they're asking the similar question. They're saying instead of select 16, it is select 17. That's the only difference, right? So let me take this question, okay, on the next page, and let me try to answer this question. So they are saying that which of the following represent the same network. So see, it is select 17, which means 17 bits must be fixed. It's also easy question. So they are saying 3.128 means 1 followed by all zeros. 3, 1, 2, 3, 4, right? Dot 0, select 17, right? So this is basically saying that this must be same. Okay, I mean, these are the 17 bits. This must be same, and then you can write anything here. Okay. So you can you write 75 here? Yes, you can write. I mean, as long as see 128, if it is 128 or larger than 128, because if I'm changing something here, then it will be larger than 128. If it is 128 or larger than, see, this must be obviously same. Then if it is 128 or larger than 128, then I'm fine. I mean, slash 17 must be there. Okay, this must be there. And then if it is 128 or greater than 128, then I'm fine. So this is okay. This is okay because this is 128. This is 128. This is 129. This is also okay. This is 192. This is also okay. Okay. So you can say since this is 1, which means 128 is minimum should be there, and then you can keep changing this. Okay, you can write anything greater than 128, right? So anything greater than 128 is fine. Anything greater than equal to basically 128 is fine. Suppose one of the option is 152.3.64, or I mean something lesser than 128, maybe 127, 126 or anything. Okay, 120.0/17. Okay, then this is not the answer, right? Similarly, if one of the option is something like this, 152.3. Okay, 128 only. Okay, .5, something like this. But here select 16. Then obviously this is not the answer, because this is only saying that okay, keep the 16 bits fixed. Okay, this is representing the different network. This is representing the network which is the higher than this. I mean, which is superset basically. I mean, this is this can have the network like .0 also here, but your original network cannot have 0 here, right? So that's why this is also not the answer. Okay, this is representing .02 152.3.255.255. So this is also not the answer, right? This is also not the answer. This is also not the answer. Okay, these four the possible answers. Understood? So basically in the classless notation, okay, this it doesn't matter what you are writing here. Okay, generally we write the network ID. See, for this network, this is 1 and everything else is 0, this is 0. This is the network ID, right? Generally we write network ID here, okay? This generally is the network ID, right? And then slash notation, but you can write anything. Instead of network ID, you can write 75, 15, 129, 192, anything you can write, right? All of these are representing the same network. Okay, let me take another example. For example, suppose you have something like this: 192.3.5.6 slash, let's suppose 18. Okay, something like this, slash 18. Then it is saying initial 18 bits are fixed, which means these are the 16 bits, then 2 more bits. Here, if you represent this 5 in binary, then 2 bits, basically initial 2 bits, I do not even care about the remaining bits, but yeah, initial 2 bits will be basically 0, right? Initial 2 bits are 0. I mean, 192.3 dot, basically this will be 0. So you can say that as long as these two initial 2 bits are fixed, so which means you can write anything, right? I mean, if you write let's suppose this is 128, this is 64, you can write anything which is lesser than 64 here, okay? Which means if you write 192.192.3.62 dot anything here, okay, 5/8, yeah, this is same, okay? This is same as 192.3.5.6 18, okay, /18. This is same as anything you write lesser than 64, okay? Anything you write lesser than 64, 192.3 dot, and now anything you write lesser than 64, which is, let's suppose 58 or anything, okay, 54.5, okay, /18. Yes, this is also good, okay? Something like 192.3.50.255. Yes, this is also good, /18, right? This is also good. Is this also good? 192.3 dot, let's suppose 128.3 or something like this, /18. No, this is not same as, this is not same, okay? This is a different network, right? So all of these are same, but this is a different network. This is a different network. Why? Because here the network ID itself is different. Here the network ID will be having first one, right? Network ID itself is quite different. I hope you understood. So this is a completely different network. So now I hope you are able to understand that how to identify or how to basically understand this slash notation, right? So whenever you're writing slash, it means you're representing an entire network. It means it is saying that initial 18 bits are fixed and then rest you can change. Okay. Okay, so that's all about the classless addressing. Now there is one concept called network mask. So basically, when we have the something like slash notation, something like this, then can you tell me the network ID? Yes, I think you can say the initial 24 bits are fixed and then you can change the remaining, right? So what is the network ID? As humans, right, we know that first 24 bits are fixed, hence the network ID is this, right? Network ID we can easily find out because we know the first 24 bits are fixed and remaining you need to keep 0 for the network ID. Okay. But as a router or as a machine, how does a router determine network ID? Okay, router needs network ID little bit, you might know, because of the forwarding. We will see how the forwarding happen in the detail, but router needs network ID, that is for sure. So hence the natural question is that how does router determine? I mean, as a human we know that okay initial 24 bits are fixed, but router router has to do something, right? For the router, by the way, these all are the binary numbers. I mean, for our sake of understanding we have converted to the decimal, but for the router it looks like this. Okay, even router doesn't even see the dots in between, but anyway, that's fine. Okay, ultimately router has to convert this 10 to 0. Okay, I mean in binary if you see, then router has to go from here to here. So how does the router can go? Because router has to take has to make use of the information of the /24, that is for sure. I mean, using the network mask only, router can say that okay, initial 24 bits are this and rest I need to change, right? So router uses a binary operation, because in binary the and or operation, these things are basically quite easy and quite, you can say, fast also. Okay, in terms of the binary operation, and or operations, these are quite fast. So router convert this /24. Okay, this is also called network mask. This convert to the binary. It says that okay, 24 ones and then all zeros. Then router does one thing. Router takes, okay, you can see that okay, what I need to take, and or. Router does some bitwise, I think, AND operation. I mean, I need to copy all of this, right? So I need to take AND operation. With the OR, I think all the ones will be there. So router does AND operation between these two. If you do AND operation, then all of this will be 0, converted to 0, because 0 and anything is 0. All of this will be as it is, right? So router does the AND operation. Okay. So how router is getting this network ID? Using the AND operation between these two. Okay. AND operation. See, you don't have to do the AND operation and all. I'm just telling you. Or maybe it is not much useful, but still you should be knowing that how router perform this calculation. So router have the IP address. Router represent network mask as a ones and followed by zeros. Okay, and does the AND operation to get the network ID. We will see more practice of it. Don't worry. But I hope this example is clear, right? This is the first example, and I hope this is clear. Let's just see more practice of it. So slash 24 means router will convert the 24 ones and then followed by all zeros. These are called network bits and the host bits. Let's just see. See, what is the network mask corresponding to slash 22? Okay, subnet mask or network mask both are fine. So slash 20. Slash 20 means 20 ones. Okay, 20 ones. Okay, these are, let's suppose 8 ones. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are the 16 ones, and then 4 more ones, and then zeros, right? 4 more ones and then zeros. So this is obviously 255.255.255. 255.255. Sorry, this here you will be having 4 ones and zeros. Okay, in the third octet. 255.255.4 zeros. Okay, so this number is you can calculate 128 plus 64 plus 32 plus 16, right? 128 plus 64 plus 32 plus 16. Or in other words, you can subtract from 255. I mean, whole is 255. You can subtract this number, which is how much? 15, right? So you can subtract 15 from here. This is 0, 4, 2, 240. So this is 240. Okay, and then again all zeros, right? All zeros. So 240.0. So I think B is the correct answer. I hope you understood. Okay, so slash 20 means 20 ones and zeros. Okay, this is how you represent the network mask or the subnet mask. Okay, if currently this sub is bothering you, that's fine. Sub means small. Okay, the small and large is basically relative things. We will see subnetting also, but yeah, subnet mask or network mask both are fine. Okay, so first 20 bits are set to 1 and remaining bits are 0, and that's how you get this answer. Understood? Easy question, but I hope you understood. Now let's solve this question. In this question, they are saying this slash 28, and then they are asking the first address. That's also very easy. So 205.16.37, these are the 24 bits, and then 4 more bits you have to take, right? So 4 more, you can represent this in binary, and then you can solve this question. Probably that's the that is solved next. So address is this. Okay, so you can represent this in binary, and as a human we know how to solve, but as a router also or as a computer also you can solve it. Basically slash 28 you can represent 28 ones and then 0, and then you can take the AND operation, and then you will getting this as answer. Okay, then you will getting this as answer. So I hope now you know how router does it, and obviously as a human you obviously know that how we do it, right? Okay. So now let's just see, find the network address of this. So again, you can find out this is the IP address I've already represented for the sake of not letting you convert to the binary. So I have represented this in binary. Then you can write 24 ones. Okay, all the ones here, all the ones here, all the ones here, then all the zeros here. Then if you take the AND operation, then it will be copied as it is. Then this will be zeros, right? So 192.168.1.0. I mean, this is the first address or the network address. Okay, slash 24. So this is the basically, I mean, slash 24 is the entire network, but if they just ask you the network address, you can only say this much only. Okay, the network address is this much only. What the entire network is slash 24. Okay, you can write slash 24 here also, you can write slash 24 here also. Both are representing the same network. Similarly, you can solve these first address questions. These are the easy questions only. Okay, all are asking the first address, network address or the first address. Okay, great. So now you know that how to basically convert given network with the slash notation to the first address. Okay, how to know the first address, how to know the last address, and what is the network mask. These are the few small details that I wanted to convey with the classless addressing. So now you know the classless addressing. Now you know the first, how to find out the first address, last address. Now see, this particular MCQ was quite important to understand. Let me again reiterate this particular MCQ. It is just telling you that given an IP address with the slash notation, it is representing the entire network. and then network can be represented with the different IP addresses with the slash notation. Okay, as long as these 17 bits are fixed, you can keep changing these bits. Okay, so that's fine. Okay, that's all.